Hello guys, so today we are going to be talking about abstract contracts and Solidity, okay? So with that being said, let's get straight right into it. Right. So abstract contracts and Solidity are actually contracts which actually have at least one function within it which is not yet implemented, okay? So this actually helps as a blueprint, or let's say as a predefined structure which other contracts, when they actually inherit this contract, they should define or structure the functions within it as specified, okay? So if you don't understand what I just said, probably let's get straight right into it with the code so you can be able to understand from a practical perspective, okay? So to actually initialize an abstract contract, we must always use the abstract keyword, as you can see, okay? So what we have here, we have three contracts, all right? So the first contract we have is an abstract contract. So we named it abstract contract. It's just the naming. You can name it whatever you want. The second contract we have here is the derived contract, okay? And we made it to inherit the abstract contract by using the is keyword, okay? And the third one we have is the call contract, right? Where we are literally going to be demonstrating more on how we can be able to like use abstract contracts here, right? So let's get to the first contract. If you don't understand the concept of inheritance, okay, in my previous video I made a clear video on how you can be able to understand concepts of inheritance while working with Solidity, okay? It's very important, right? So with that being said, let's get straight right into it, okay? So let's assume, let's try to create a function. Let's say we have a function and let's call it get str, all right? Let's say this is going to take a parameter. We're going to say it's going to take a string in memory. Okay, let's just underscore str in, okay, and we are going to make it public view, and it's going to returns a string. All right, that's a string memory, right? This is critical. So you have a function get str that takes one parameter, right? And remember, since this is the abstract function, I was trying to initialize this already. You're not supposed to initialize the contract, okay? So rather than using curly braces, this is how the contract is going to end, like, right? You're simply just going to have a contract, a function that says get, you have a get str string memory, okay? And it's going to have, it's going to be public, right? View returns a string, okay? And let's see what's going on here. Okay, guys, so when actually defining an abstract function, right, you must actually use the keyword virtual, right? It's very important for you to know this. This is because it helps with the ability for you to be able to override this function when you're trying to re-implement it, okay, in the child contract that's going to inherit the abstract contract, right? We are going to see more of this in the upcoming contracts, which we are going to be doing below, right? So this is literally how you're able to like create a function, right? As we said, an abstract contract is literally a contract that has at least one function which has not yet been implemented, okay? So literally all you do is you define the structure. It simply means any contract that is going to be inheriting this abstract contract, okay, it has the ability to implement this function which we are creating now, the get string function, okay, and you must take a parameter that's going to be a string, okay, and it's going to be public view, okay. This virtual keyword we are using here simply means when this particular function is going to be inherited, it must actually have a keyword which we are going to be seeing below, which is going to be override, okay, for you to be able to override that particular function when implementing it, okay. Let's define a couple of other functions. Let's say we have another function as such, and we are going to call it let's see, set value, okay. Okay, so we have it like set value, and it's going to take two parameters. Let's say int, let's see, let's go underscore int in one, And the next parameter which is going to be taken is uint. Let's underscore in into, right? And we are going to set this to public. We're going to call this public. We are going to set it to virtual, right? This virtual keyword is very important while you're working with Solidity smart contract, okay? Because it helps you to be able to it helps the base contract or the inheriting contract to be able to redefine this contract. You might not understand what I'm saying right now, but when we start when we start implementing these functions, you understand why it's important for you to use these keywords such as virtual, right? So it's very critical while working with Solidity. Okay. So with that being said, let's get to the next function. You can equally define another function as such. Let's say we have another function. Let's say function, and we can just say add, okay, and this function is going to, let's set it to public. Let's set it to public. Let's use the public virtual returns uint, okay. So this is the standard which we are trying to say here. Okay, well, we're just simply saying that, okay, this is the abstract contract. This is literally like a blueprint or a structure by which any contract that inherits this contract when implementing these functions must actually take this standard, okay? So it's very important. You don't implement the functions here. You just literally describe the blueprint as to how you want the functions to look like. And when these functions are being implemented, they must actually follow the same procedures. At the same time, they must use the keywords override, okay, because they're trying to like override, or they're trying to like implement these functions which were previously actually defined in the abstract contract, okay. It's very important for us to know this, okay. So with this being said, let's move forward to the next contract, okay. Let's say we have another contract here which is called derived, okay. The function is called derived contract, okay, and we use the is keyword to say that this is keyword is an abstract contract, right? So we already have an error here, because since he has an error because we have not yet implemented the functions which we actually defined in the abstract contract, right? When we define these contracts here, then everything is going to be right, okay. But before we get started, let's try to like define some variables, okay. Let's all have uints. Let's name this as private, okay, and we're just going to say num1. Let's say another uint private. We are going to call this num2, okay. Now let's define functions. Like you can see, we're going to be defining the functions inherited from the abstract parent contract, okay. It's very important. You need to define these functions now. So while defining the functions, we're like, you can say function. We have to get str. Remember, it must be same as in the abstract contract, right? Remember, in the abstract contract, we actually define the function as such. It has to be same, taking same parameters, okay? It's very important for you to know this. So we can literally just copy the same line of code. We can just copy the same line of code. And I should copy this, Control C, and if we are pasting that here, let's say we are pasting that here, Control V, okay. Now I'm going to be taking off this. I'm going to actually replace it with curly braces, okay. And now we still have an error here, okay. We need to change this keyword to override. Okay. After changing this keyword, we still have an error here because we haven't implemented all the methods here, right? When we do implement all the methods, then we won't have the error, okay. Since literally in the abstract contract, we created a blueprint or the structure by which we want every contract which actually inherits this particular contract should be able to must actually implement the predefined contract. So after we implement the predefined contracts, then we won't get an error, okay. So within this, we are going to return, this is the implementation, return, let's say underscore strin, right? Because literally this is the string which we are going to be getting from here, right? So now let's define the other function. Let's say function. We can copy as before. Okay, let's say let's copy in order to save time. Control V. Let's say we have this function as such. This was the second function which we used. Okay, and remember we have the override keyword. Before in the first function, okay, it was public virtual. Now in the next one we have public and override. Okay, it takes two parameters, just same like before, but the difference here is the method is being implemented. Okay, we are literally just setting num1. Okay, we are just setting the state variables. We are instantiating them. Num1 has a value of in1 and num2 has a value of in2. Okay, it's important. Same thing as the add function, right? Literally the same thing is going to apply to it, where we can always just implement it by saying copy the first function which we were using, the add function. We change the override, we change the virtual, the keyword, from the abstract contract to override, and literally we implement the function by making it return a sum of num2 plus num1, literally which was initialized here, and literally we get these two numbers and we add the two numbers right at the bottom here. Okay, so what's happening here, we're literally following a particular blueprint which we actually set in the abstract contract, which we are saying for every contract that inherits this abstract contract, it must have these three functions, right? Here we do not implement the contracts, but literally when we come to the inherited contracts, all we must do is we must make sure we implement the contract. Okay, so this is what we are doing right here, and these are our functions, right? So it's very, very important for us to note this, right? So now coming to the caller contract, is the third contract which we are going to use to be able to demonstrate how you can be able to use abstraction, right, in Solidity. Okay, so let's say we are going to create an object. We are going to create an object of the abstract contract. Okay, so we say abstract contract, just call it ABS. Okay, and we are going to create a constructor. Let's say constructor, let's set it as such, and let's say ABS is equal to new derived contract. Let's save it as such. Let's save it as such. Let's save it as such. Okay, I'm running into an error. Let me see what's happening here. That got expected semicolon, that got constructor, ABS. All right. Okay, I think this is where we have an issue. Okay, let's call it ABS with semicolon, right? That's where the issue was. So in this abstract contract, what we're literally doing here is, let me explain what is happening here. Literally, we are creating an instance of the abstract contract. Okay, so this is ABS. Okay, we're creating an instance of it. Remember, you cannot, you don't have the ability to instantiate an abstract contract because it has no functions implemented. But you can be able to instantiate an abstract contract. You can be able to instantiate a contract through the abstract contract which inherited the abstract contract, right? What we're simply trying to say here is we literally have a derived contract, okay, which inherited the abstract contract. So that's why in the constructor, a constructor is a function which literally runs just once when the smart contract is being deployed on chain. Okay, so when this contract is being deployed, what's going to happen is it's going to like create an object of the abstract contract using the derived contract. Okay, so we can be able to access all the functions from the derived contract, right? So if you don't understand what I'm saying, maybe you can watch the video one more time or through the examples or how we are going to use this to be able to understand, right? It's very critical what we are seeing here, especially when working with Solidity. Okay, so now let's say we have a function and we are going to call it get value, values, and this function is going to take it's not going to take any parameters. Let's leave it as public views, not really necessary, and just a public returns. Let's make it to have a return value of, let's make it to have two return values, literally a string, okay, and this memory, comma units. It's very critical for us to know this. Now within this, we can now be able to do some return statements where, first of all, we need to be able to set some value, say abs, okay, abs dot set value, which is going to take two parameters. We can give it some values like 10, 16, and because we need to set this first. Why are we setting this first? Because we cannot be able to return the unit value if we haven't set these values first. Okay, the unit value is going to come from an addition. That's why let's get done with the code first. We have a return statement here that's going to look like abs dot get str, and we are going to give it let's just give it a string of concept of abstraction. Okay, and let's give the uint, and we can use abs dot add. We give it two parameters. Okay, we can just say abs dot add literally. I think it's gonna be okay because we set the values like this. All right, so semicolon, and here we have no errors. Okay, so if you don't understand what's going on here, this is another level of account abstraction. Okay, in the first level of account abstraction, what we're literally doing is we're implementing the derived contract, okay, which literally was a child of the abstract contract, right? In the abstract contract, we just implemented the methods, we just instantiated, we just gave a blueprint or a structure as to how the methods will have to look like, okay? And we did not implement these methods, right? So in the derived contract, which inherited the abstract contract, all these methods were being implemented, okay, and we set some values here, right? It's very important for us to know this. Then we have these functions. This is already on its own a pure concept of account abstraction, but we went further on how you can be able to use it. You can equally be able to create an instance of an abstract contract, okay, and this is how we did it using the derived contract, okay, within our constructor. Now what happened here was we wrote a function called get values, which literally returns a string value and a unit value, okay? So to set these values, remember, since this abs instance has the ability to access the derived contract, remember we have in the derived contract, we have a function called set value, okay? So we are using the abs instance to be able to access the set value function, and we set the two values, that's num1 and num2, okay? We are setting these values, and then in the return statement, we're using abs, this contract, to be able to get the string, okay? We are setting it at the same time, okay? We are setting it to have an input value of concept of abstraction. At the same time, we are returning the abs.add value, right? So it's going to add num1 and num2. So this is where we're using the get string. We sent in a string the concept of abstraction, and it actually returns what we put in, that's str in, right? So that's the main concept of abstraction, right? So it's going to be good for you to rewatch this video and actually try to implement your own functions, or try to implement your own contract, which is going to help you while dealing with abstract contracts, okay? So with that being said, I look forward to seeing you guys in the next video, okay? So don't forget to click the like button, subscribe, and share. So see you in the next video.